So today we're going to talk about lesson 31, adding integers and collecting like terms. So when we add integers, we're going to add numbers that are both positive and negative. So we always have positive and negative numbers, but today we're just going to add those. So we're going to use this example to get started. If the temperature in the morning is -4 degrees, but increases 10 degrees by noon, what is the noontime temperature? So what we want to do is we want to be able to add these integers, and the problem tells me those integers. My first integer is -4 degrees, and it also tells us that it increases, so I'm going to add, and my number there is 10, so I'm going to increase it by 10, and I need to know what that temperature is by noontime. So if I have -4 degrees plus 10 degrees, many of you already know that -4 plus 10 gives me 7 degrees. But some of you that don't know that, we can look at our number line. That was a very straight line. So we start at 0, and I'm going to make my number line. So 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. So the first thing I'm going to do is I'm going to start at 0. My first number is -4, so I'm going to go to -4. 1, 2, 3, 4. And then I'm adding 10 to it. So if I add, I'm going to go to the right because it's a positive number. It's a positive number, so I'm going to go to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what my spot is. And if I look, so I'm going to go 5 and 6. And so that's my answer. My answer is going to be 6. I'm sorry, I wrote that wrong. -4 plus 10 is not 7. It is 6. So we're going to use another example to help us with this. Sam has no money and owes his friend $5. If Sam earns $15 washing cars, then he can repay his friend and have money left over. Write an equation for the situation and find how much money Sam has to offer has after he repays his friend. So Sam starts with $0. So Sam starts with 0. He then owes a friend $5. So if you owe somebody, you're going to give away $5. So you're going to be -$5. Then Sam earns tells me I'm going to gain it, so I'm going to add it, $15. I need to know how much he's going to have after he repays his friend. So if we start here and we use our number line, so he started with 0. He then had to give away $5 of it, 1, 2, 3, 4, 5. And then he gained 15. So I'm going to go 15 to the right, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I add 15 to -5, my total number that I am going to have left is $10. So when it tells us to write our equation here is this right here. And we were able to tell that we had $10 left. And we cannot forget our labels because those are what determines what our answers are. So here we're going to look at these number lines so you can actually see the number lines and not my awful number lines. So I'll use a different color on each number line. So we always start at 0. And my first number is -3. So I'm going to go to the left 3. So 1, 2, 3. Then I'm going to add a +5. So because my 5 is positive, I'm going to go to the right 5. So I'm going to go 1, 2, 3, 4, 5. And that number there is +2. The next example, I'm always going to start at 0. Let's use orange. So I'm always going to start at 0. My first number is a positive 3 this time, so I'm going to go to the right 3. 1, 2, 3. And then I'm adding a negative 5. And because my 5 is negative, I'm going to go the opposite way to 5. So I'm going to go 1, 2, 3, 4, 5. So my answer there is going to be negative 2. So even though we have the same numbers, because the integers are different between positive and negative, that's what changes our end value. So if we look at our last example, I'm going to have negative 5 plus a negative 3. So I'm going to start at 0. I'm going to go to the left 5, 1, 2, 3, 4, 5. And then I'm going to add a negative. And because my 3 is negative, I'm going to go to the left again. I'm going to go 1, 2, 3. So my final answer there is going to be negative 8. So we're now going to find the sum of these values. And I'm going to use one number line. That way you don't have to see me draw each time. So I'm going to go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, negative 6. So my first one, I have 6 plus 2, and with my 6 plus 2, I'm going to start at 0, I'm going to go 6, and then I'm adding 2 more to the top of that, so I'm going to go 2 more, 1, 2, and my final answer there, if I add that, so 6, 7, 8, my final answer is 8. And many of you already know that 6 plus 2 is 8, but this is just another way to look at it. I have my next example, I'm going to use blue for this one, 6 plus a negative 2. So I'm going to start at 6 again, so 0, I'm going to start at 6, but this time I'm going to go to the left 2 because my 2 is negative, so I'm going to go 1, 2, and this value here is 1, 2, 3, 4, so my value is a positive 4. For negative 6 plus 2, I'm going to start at 0. I'm going to go to the left 6, so 1, 2, 3, 4, 5, 6. And then it says I'm going to add a positive 2, so this time I'm going to go to the right 2, so 1, 2. And my value there is negative 1, negative 2, negative 3, negative 4. And my last number is negative 6 plus a negative 2. And if we remember right from the last time, from our last example, if I have two negative numbers, I'm always going to go to the left. So first I'm going to go left 6, so 1, 2, 3, 4, 5, 6. And I'm also going to go to the left another 2, so 1 and 2 gives me a negative 8. So my answer is negative 8. So we just have to make sure that we look at our signs to make sure we are going the right way on our number line, or making sure that we add them correctly. The next part of this lesson is simplifying and collecting like terms. And the term is an expression that includes a positive or negative number and may include one or more variables. So this 3y here would be a term, and the number part of the term is called the coefficient, and this may be review. So if you feel like you understand this, you may go skip forward a little bit on the video. But if not, the 3 is our coefficient, so it's asking us what are the coefficients. So my coefficient in 3y is going to be 3. My coefficient in 2x, just the number, is just 2. My coefficient in negative w. We always know that w has a coefficient of 1, but because it's negative, my coefficient will then be negative 1. And our last one is negative 7. So my pen does not want to mark on there. So negative 7 is going to be, it's beautiful. There we go. So negative 7 is my coefficient on negative 7z. We're going to simplify these expressions by collecting like terms. And like terms are terms that have the same variables and the same exponents. So when we see these values, these like terms, what this is x to the first, y to the first, and 2x to the first and y to the first. Our coefficient out front doesn't matter, we're just looking at our exponents. And if it doesn't tell us an exponent, we automatically already know that the exponent is 1. So these are like terms because they have the same variables and exponents. If we look at our unlike terms, we can notice here that I still have a 2x, but that doesn't really matter with our unlike terms. And our exponents here, I have a 2 with my x, I have y to the first, x to the first, and y to the first. So because these are different and they're multiplied together, they are unlike terms because of this 2 right here. If you guys have any questions, make sure you're asking those in class. So we'll use a couple examples. So we're going to simplify by collecting like terms. So here I have 3x to the first. Like I said, don't worry about the coefficient out front first. We want to make sure that we have the right exponents. So I have 3x to the first plus 2 minus x to the first plus 3. So what I'm going to do is I'm going to circle my common terms. So I have 3x to the first and a negative x to the first. And I'm going to combine those. So I have 3x minus x, and then I have plus 2 plus 3. That way it's easier to combine. So 3x minus x. So if I have 3x and I take away an x, I now have 2x. And if I have 2 plus 3, I'm going to also have 5. And that is our simplified version right there. So if we look at our next example, I have 3x to the first again, minus 2 plus 8x to the first plus 9. And you don't have to mark these ones. It's just easier to say, okay, they both have the same exponent because they have 1. But if they have just x, you're fine. You don't have to put that 1 up there. So I'm going to combine my like terms. So I have 3x, and my sign goes with that number. So I have a positive 3x, or 8x. So I have 3x plus 8x. And then I have plus 9 and minus 2. So I have minus 2 plus 9. So 3x plus 8x is 11x. And negative 2 plus 9 is going to give me a positive 7. And that would be our simplified version there as well. And in my last example, use purple instead. I have 3xy minus a negative 4xy. And if I look here, my x is going to be x to the first, y is going to be y to the first, and here I have x to the first, y to the first. So I can just add these together. But it's telling me to subtract. If we remember right, we can change any subtraction problem into an addition problem. So if I change my subtraction into addition, I have to change all my signs after that. And the only sign I have to change is to my negative 4. So this becomes a positive 4xy. So I can add these together. So I have 3xy plus 4xy. And I can just add my coefficients there. So I have 7xy. And that would be our simplified version. So anytime you are subtracting a negative, if you are subtracting a negative, it means that you are adding a positive. And that's something to always remember.